All right, let's define this. There's actually two I'm going to compare here. There's X bar and R. Does anyone know what the letter R stands for in this definition? Control charts. It's range. So if you have a sample of 2 parts with observations 10 and 15, what would be my range on that? It would be 5. All right, so X bar range charts are very simple to perform. What is a X bar S, small letter S chart? Sigma, yes. And what does sigma stand for? Someone else can answer? You don't want to hog all the attention. Standard deviation. So both of range and standard deviation are a measure of dispersion about the central tendency. All right, so a range chart, let's back up. What is the benefit of plotting both the central tendency or the average of that sample and the range on charts typically directly above and below each other?
So you can determine what your average range is to see how much, if there's an unusual variation or something, if your normal range is 2,000s or something, and it shows that it's jumping high and low, it shows you that there's something going on in the process.
Right. So another way to say that is if we plotted only the X bar, it is possible by the collection of samples that you could have the same. Let's try to give this example on the fly here. If I have a sample of the parts that are 10 and 15, let's make my math easier, 16. What is my X bar for that? That's going to be 13. I could also get to the same point by saying 9 and 17, right?
And you're expecting very well maybe 13 plus minus 1, and all your data failed, but your X bar would have showed you were in range without a range also applied.
Yep. Or another example is maybe, let's say that your acceptable range is 10 to 16, and you've done all this preliminary studying, and you prove out your chart, and you just run along, but then you start, if you don't plot the variation at the same time, you miss that the variation may, it can also go the other direction. It might go 11 to 15. Is that always good? We normally think that reducing variation is a good thing. The only time it's a little bit dangerous is someone doing something that could be beneficial. Or maybe there's an employee that has more consistent product, but that would never be observable if you only looked at the means. So that's the reason you plot both of these at the same time, is you're primarily interested in whether there's a shift of the central tendency, but with the range you can also detect if there's a change in consistency or variation. All right, so there are steps given in our book. I'm going to give a couple just quick definitions. N is the sample size. So typically with this X bar, if you have an X, that is the actual observed reading, or it's the data point, an observation. So X bar, where the chart is named after, that's the sample average. And then there is, what is X double bar? It's the averages, it's the average of the averages. So you're going to get a sample average, but your X double bar is your central point of the center line of the X bar chart. R is range, we already talked about that. And then R bar is the central line of your range chart. Right, frequently it's common to collect 25 samples. It's not an exact numbers requirement, but remember from statistics, the more you collect, the more confident you can be of picking up on that. Challenge is, the more you collect, the longer you're delaying yourself from actually using a control chart. So no sense to get too obsessed with that. So remember, though, that when I say samples, if you have a N equal to, let's do our math easier again. If your sample size is 2, how many actual observations based on this guideline would you have to have? 50. Does that make sense to everybody? Also remember that these samples are based on your rational subgroups that we just talked about. So what you're going to do is calculate your samples, then you will create a table of your sample averages. You're going to plot those in time sequence. You're also going to calculate your ranges. And typically you're going to get, the other thing I'm going to show you is that there's a chart on page 13. You may see these types of notation in these tables related to creating X-bar charts. And I'm not expecting you to write all these down, I'm just going to show where these plug in. So the classic definition of a X-bar chart, your upper control limit is equal to the grand average plus this A2 times your range. So if you're using N of 2, your A2 value is 1.88 times the range. So if I just give you a range of range equals to 5, and it averages that, and our central tendency was 13. Times 5. Does that kind of make sense to everybody how to do that?
So that number stays constant, that A2, depending on what you're using it for?
Depends on your sample size.
Sample sizes, okay.
Then your lower control limit is X, the grand average minus A2 times that. Your R chart's going to have lower control limit, upper control limits as well. That is D4 times your average. And you're using this table once again example, our upper control limit is going to equal 0.27 times 5. Lower control limit's going to be 0. So a question for the practitioners, how many of you perform manual control charting? No? Right? Do we have a yes for anyone that manually does them? By calculating by hand, going to the table, looking it up?
It's a waste of time and a potential source of error.
Exactly. So this is the X bar chart. The one thing I would like to propose is, I don't even know if it's actually talked about in our notes here, that I'm an advocate of, and that is run charts. So basically my contention is, if you don't have time to go through and do this and you don't have Minitab, and you're not using any control charting at all, just start plotting the X bar. Does that make sense? And the reason I'm saying that is I think that too many times people get enamored with trying to have a perfect control chart when what we're looking for are trends and triggers. And if you do want to put control limits on there, I often just go, I do the 3 times the sigma plus or minus. It's just I'm going to get something started. I'm not going to make it more complicated than that. In that case, I'm probably talking about an X bar sigma chart kind of mindset. But just get the data plotted in a time series manner, because if you're choosing reasonable rational subgroups, the chart of just the time series will typically give you clues of, wow, this has always been going up, or this is always going down. And the human mind is able to pick out many trends that there may not be a mathematical explanation for. Does that kind of make sense? Because random should be alternating typically either side of the central mean. But if it's, most people can tell if a trend is going up or down, or if the variation is jumping all over the place with that. So what I'm going to ask you guys to do is we're going to create a, basically it's going to be a run chart idea. And what my mindset is, we're going to, what I've done with other classes is we throw a piece of wadded out paper towards a target, and then I'm going to instruct you to do something else, and we'll see if the control charts pick up the process shift. Does that kind of make sense what we're talking about? So it can get a little bit crazy with this, but our goal is to, and for simplicity's sake, let's just, you don't have to use a precise measurement tool, but if you have a ruler, you can use it. If you don't, you can even just use the floor and count the tiles would be a unit of measure. And what I want you to do is to do 10 samples, plot those. Let's do n equal to 2. And I want you to plot X bar and R directly over the top of each other. We're not going to worry about the control limits for right now. And I want you to break into groups. You can be in as big a group as 5. Now let's just make it simple. Each row across here will be a group. How about that? And that way, all the way across is working together. All right, so that also makes it easier for my idea of, for example, that you stand at the wall and then you have a target square and you try to get to that target square and you're measuring the distance from that target. And then I'm going to introduce a shift to the groups, and we'll see if our chart can show when that shift took place. Does that make sense, what the goal is? Because that really helped me the first time that I did this type of exercise of when the chart matches with the your real life example, it helps you appreciate, okay, the chart will give me that picture that there's something different. Okay? So that's what we're going to do, and let's see if we can get that done by 7 o'clock.